This lesson covers the principles of electrical science as part of the electrical installation course via City and Guilds. This is my interpretation of the subject matter and hopefully provide some assistance. The key topics we will cover Ohm's law, resistors in series and parallel, the power equation, AC versus DC, and an introduction to capacitors and inductors and transformers. So Ohm's law, voltage equals current times resistance. Voltage measured in volts, current measured in amps, often using an amp meter, and a resistance measured in ohms. For example, if the current flowing through a circuit is 3 amps and the resistance is 4 ohms, what is the voltage? Well, using the triangle, if we want the voltage, then we're left with current times resistance. Current being denoted by I. So the answer would be 3 times 4 is 12 volts. In this question, it states if the circuit has a voltage drop of 10 volts and a resistance of 5 ohms, what is the current? So in this case, we want I, which is the current, so we're left with voltage divided by resistance. So in this case, 10 divided by 5 equals 2 amps. Finally, if the circuit has a current of 10 amps and a voltage of 230 volts, what is resistance? So again, this time we want the resistance, which we're left with voltage over current. 230 divided by 10 equals 23 ohms. Resistors in series. So if you imagine a series circuit is where the current has to pass through all of the resistors on one circuit, or one path, if you like. So we simply add up the resistances together. So in this example, we've got 3 resistors, one 2 ohms, the next one 4 ohms, and then finally 6 ohms. So the total resistance of the circuit will be 12 ohms. In this question, if we then wanted to find the current going through the circuit, and we had a 24 volt supply, then it would be current equals voltage over resistance, which in this case is 24 divided by 12, or 2 amps. Resistors in parallel. This is where it branches off into different pathways that the current can take. And the equation looks like 1 over total resistance equals 1 over resistor 1, 1 over resistor 2, and plus 1 over resistor 3. So in this example with the resistors of 2, 3, and 4 ohms, 1 over the total resistance equals 1.0833. And then if you move the total resistance up and then divide through by the sum of the parallel resistances, you have 1 over 1.0833, and you're left with total resistance 0.92 ohms. Okay, power. Power is measured in watts, and there's 3 different equations. One is power equals voltage times current. Another one would be power equals current squared times resistance. And finally, power equals voltage squared over resistance. So all you would do with this type of question is look at what values you're given and then find the appropriate formula. So for example, if a circuit has a voltage drop of 24 volts and a current of 10 amps, what is the power? So the question gives us voltage and it gives us current. So on this one, we can use formula 1, power equals voltage times current, 24 times 10 equals 240 watts. Okay, so AC versus DC. AC is an alternating current, and we've displayed that on the slide, the curved graph. Alternating current usually used in ohms, and for example, the UK main supply is 230 volts and 50 hertz. 50 hertz is the speed at which the current alternates. A DC current or direct current is found in batteries. You have lots of sizes of batteries, 1.5 volt, 9 volt, or 12 volt car battery, for example. Capacitors and inductors. There's lots of equations around these, but for now we'll just introduce the topic. A capacitor stores energy in an electric field, whereas an inductor stores energy in a magnetic field. Both are used in filtering and smoothing circuits. Again, transformers is a big subject with lots of different equations, but I'll just introduce it at this point. So, we have a primary coil and a secondary coil. It works through electromagnetic induction. A step-up transformer increases the voltage, and a step-down transformer reduces the voltage. Ideally, if there's no losses, power in would equal power out. Thanks for watching. That covers a brief introduction. I will provide some practice papers with answers in the comments below, and if people want more of this, I can go into greater detail in some more of the subject.